This first question is talking about a frictionless roller coaster. It gives us a mass of 800, and it tells us two different time points. It says that at the initial time point, it has a speed of 4 and a height of 35. And then at a second time point, it has a speed of 20 meters per second. So we're going to assume that this is in an isolated system. And the first thing it's asking us for, so for A, what it's saying is it wants the initial mechanical energy. So that means it wants the mechanical energy at the first point that it's talking about. We know that our mechanical energy is going to equal our kinetic energy plus our gravitational potential energy. In this case, because we know we're only looking at the first point, we can put ones beside all of these because we know that we only want it for the first situation. We can say that we know that we want half mv1 squared plus mg and the height at number 1. Then we can put in all of our numbers. When we multiply these all together, what we will get is we have 6,400 for the first, our kinetic energy, and we have 274,680 for our gravitational potential. When we add those together, we get 2.81 times 10 to the 5 joules. For B, what it's asking for is the gravitational potential energy at the later time. And what we know already is we know that our EM1 is equal to the number that we just calculated, 2.81 times 10 to the 5. But we also know that that has to be equal to our mechanical energy at the later time. Because as we're assuming that it's an isolated system, our mechanical energy must stay constant. In this case, what we know is that our mechanical energy on both sides is going to be added up when we have our kinetic plus our gravitational potential. And what this is asking for is our gravitational potential. So we're looking for this. If I rearrange my formula here, I can say that my EP2 is going to be equal to my EM1 minus my EK2. And that's the same thing, just rearranged. So from my above question, what these two numbers actually equaled was 281,080 joules. So I can put that in for my mechanical energy 1. So I have 281,080 joules. And what I'm subtracting here is I'm going to be subtracting my half times my mass, which is 800, times my second velocity up here that I just circled in blue, which is 20 meters per second, and I have to square that. What I'm going to get there is I'm going to get a final answer of 121,080 joules, and for significant digits I have 1.21 times 10 to the 5 joules. And I'll box that up, and I'll box up my earlier answer as well. This second question is asking about a pendulum, and it's saying an ideal pendulum, which means we know that we're assuming that it's in an isolated system, and we know that energy is going to be conserved. The first thing it's asking for A, is its mechanical energy at the highest point. So our highest point is 25 centimeters or 0.25 meters. So our mechanical energy at the highest point is going to be equal to the kinetic plus the potential at that highest point, and I've called the highest point 1. So we know here that our kinetic is going to be half mv squared, and our potential is going to be mgh, so we can put in our numbers here. We know that we can put in a velocity of 0 because at that point, when we're just talking about that one point, the velocity will be 0. When we do our math here, we are going to get 0 plus 0.613125, which will get us a final answer of 0.613 joules for our mechanical energy at our highest point. For B, it wants to know the mechanical energy at the second point, so it wants to know EM2. But because we know that this is an isolated system, that means that mechanical energy has to be conserved, which we know that EM2 is going to be equal to EM1. Therefore, EM2 is going to equal the exact same thing. And I will box that up as well. For C, C is asking for the kinetic energy at the lowest point, which means our second point. So we know that our mechanical energy at our second point is going to be equal to our kinetic energy at our second point, plus our gravitational potential energy at our second point. So we can rearrange that. So we have EK2 is going to be equal to EM2 minus EP2. Then we can put in all of our numbers. We know that our EM2 is 0.613 joules minus our EP2. We know that that is going to be mgh. So we know that we have 0.613 joules minus our 0.25 multiplied by 9.81 multiplied by our height, which at our second point is 0.05. And that will give us an answer of 0.4905 joules, which into significant digits is 491 joules. Our last question here is asking for speed. So we know that we can get our speed by looking at our kinetic energy, because that's equal half mv squared, and we can rearrange this to solve for speed. If we arrange this, we know that we're going to have v squared is equal to ek2 over half m, and then we know that our v is going to be equal to the square root of ek2 divided by half m. So we can plug in our numbers here, and we can say that 0.4005 divided by half times our mass, which is 0.25. And if we take the square root of all that, we will get our velocity, or our speed, sorry, which is 1.98 meters per second.